An arrow is shot from a height of 1.5 meters toward a cliff of height h. It is shot with a velocity of 30 meters per second at an angle of 60 degrees above the horizontal. It lands on the top edge of a cliff 4.0 seconds later. A. What is the height of the cliff? B. What is the maximum height reached by the arrow along its trajectory? And C. What is the arrow's impact speed just before hitting the cliff? Okay, so there's the ground. Let's draw initial height, 1.5 meters. Initial velocity is 30 meters per second at an angle of 60 degrees. The trajectory is a big parabola, and at the end, it reaches a height y equals h. It does this in a time of 4 seconds. Okay, so part A asks for this height h. So let's look at the y component of the motion. The knowns are t and the initial y velocity. So there's the triangle with v0, v0y, and vx. So we see that v0y is v0 times sine theta 0. So, and the unknown here is y final, the h. So, and the thing we don't care about, I think, in this part is the final y velocity. So let's use this equation that doesn't contain final y velocity. Initial height, I will plug in all of our numbers, and we end up, if I plug that all into my calculator, I get h equals 27.023 meters. So h equals 27 meters. Okay, so part B was asking for the maximum height during this trajectory, during the flight. So there's the trajectory. It starts at 1.5 meters, and at some point at the top, you want to find y. And what we know here is that at the maximum height, the y component of the velocity is going to be 0. So v sub y is 0 at that point. And v0, initial v0y is v0 sine theta 0. Initial height is 1.5 meters. These are all of our knowns. What we don't care about, I think, is t. In this case, so we'll use the vy squared equals v0 squared minus or plus 2a times the change in position. Rearranging, we get that. We solve out for y. Rearranging terms again. I end up with y is y0 plus v0 squared times sine squared theta over 2g. Plugging in the numbers to that equation and plugging that into my calculator, I got 35.939 meters, so that's 36 meters. And that is higher than the cliff from the previous part, so that's good. So C is the impact speed at the cliff, so at the end of part A, I guess. So the known here is the time was 4 seconds, and I think it's going to be going down and to the right since it's beyond its maximum height. There's our little triangle. So we're going to use Pythagoras. V is vy squared plus vx squared. Let's start with the y component. The known here is the initial y velocity and t, and the initial height and the final height. And what we need is the final velocity. What we actually don't care about in this part is this change in height. So what we'll use is the one that doesn't contain height. Vy is vy0 plus at. So there's your initial. There's gt. Plugging in the numbers, I got on my calculator Vy is equal to negative 13.2193 meters per second. So for the x component, we know that the velocity doesn't change. It's the final is equal to the initial. It's 30 times cos 60. Plugging that into my calculator, I got 15 meters per second. So now going back to Pythagoras, the final v is the square root of the sum of the squares. I can plug in my vy and my vx, and I get 13.293 squared plus 15 squared. Square root is 20 meters per second.